Welcome back, ladies and gentlemen. This is going to be our Algebra 2 Function Foundations, Lesson 2, Function Notation, Homework Review, Part 3. In the last question, the last part, part 2, the last question I wrote down just said how many, but I wrote down the word home. I'm not sure why, home many, but it's how many years it would take for Ian to basically reach $5,000 in his account. So I just want to make sure I make the correction now. I'll probably make the correction in the notes for YouTube and all, but just to let you guys know, I was a little bit of rush because because I'm just doing this. It's kind of new. I've only got 15 minutes of video, otherwise it will not fit into a video. So I'm not sure how everyone else does it. No, maybe because they're long-time YouTubers and have gotten all the required hours and subscribers and all. So I got 15 minutes, so that's the thing. But we'll make it for this one, our part 3 video, because it's just one question. It's a big question though, so it's one of these word problems that you should normally get used to or seeing, so, but not beyond your ability, and we'll see how this works out. A reminder, ladies and gentlemen, if you find this video helpful, please give this video a like and subscribe to the channel to know when and turn on notifications, that little bell symbol. Turn notifications so that we know when new videos are added. We'll be going through all Algebra 2 and functions, a big deal. Want to make sure we're good with these, especially word problems. So number 5, a ball is shot from air cannon at an angle of 45 degrees with the horizon. Travels along the path given by the equation h of d is equal to 1/50th d squared plus d, where h represents the ball's height above the ground and d represents the distance the ball has traveled horizontally. Using your calculator, generate a table of values. Graph this function for all values of d from 0 to 50. Look at the table to properly scale the y-axis. And of course, asking what is the maximum height that the ball reaches, and what value does d reach? Does it reach this height? Now, I'm going to make this full screen so you can take a look here. I actually, from my table, I did values of not 0 to 50 because that's 50 values. Instead, there'll be 10 values. So actually, it looks like 11 values from 0 to 50. And so we'll make a table here. In this case, I'll write this out. Normally, I would have set up a table already and thinned it out, but save ourselves some time. Okay, maybe it's a little bigger. So, all right, move this down a little bit, and so we're gonna have here our d value. You know what it is? Because it's terms of d and h, right? Yes, d and h. So instead of using x, which I'm very normally like using, our independent variable will be the letter d. And the dependent variable will be the letter h. And we'll do 0, 5, 10, 15, 20, 25. I'll continue here so it all fits in. 30, 35, 40, 45, and then 50. I'm actually going to try to move this over a little bit here. Make some room for my calculator. Okay, so we're going to need to enter this our calculator, okay, and then the table. But we're going to make an adjustment though, because I don't want to kind of scroll through all the values. So first off, y is equal to 1 over 50. Now 1 over 50 is really 0.02, but you can type in 1 over 50. And the calculator will know to take 1 divided by 50, then times d squared. Oh, sorry, one other thing. It's negative, so we're going to bring this over here. And what we can do is, if you forget something like this, instead of erasing everything, hit second delete or insert. So it means in this case, I can insert now a value in there. Normally it types over, so you want you to do that? No, that's okay. So 1 over 50, negative 1 over 50 x squared or d squared, I believe was plus d, or in this case plus x. Okay, just want to make sure. We'll move this over a little bit here. Okay, and then we're going to go up here and see. Yep. Okay, that's our formula. Okay, so here we go. All right, and bring the calculator back. Okay, so now what we're going to do is we're going to do second table, take a second table set, because now we're going to start at 0. All right, but the change in table we could look into now is every 5. So you can do this here, and so now, since I'm doing every 5 instead of doing every 1, we'll now take a look at our table, second table. Notice how we have all the values here. Okay, so now we can just record them onto our table here. So let me just move over a little bit here, give us a little room. All right, so we have 0, 4.5, 8. So we're gonna, as I type stuff up, I'm gonna try to remember numbers 0, 4.5, and 8. So put this here, 0, 4.5, and 8. Then we have 10.5, 15, 12, and then 12.5 and 25. So 10.5, 12, I think, was it 12 and 12.5, I think? 12, yes, 12 and 12.5. 12 and 12.5. Then, here's the thing. You notice how the numbers seem to repeat, going backwards in this case. And it's probably one of the things about parabola that has that kind of reflection, if you will, of values. It looks like 12.5 is going to be the max, because here 30 goes back to 12, and then to 10.5, then to 8, 4.5, and then now is a 0. Let's double check to make sure. Yep, we got that. Great. So what we're going to do now is we're going to plot the points. So at 0, we have, maybe I'll use the green dot, so green. So 0 is 0. And at 5, we have 4.5. So somewhere, I know I can still use my finger. I can just use the pen here. 4.5 is going to be, since this is 5, that's 4. So 4.5 is somewhere over here. Notice the scale is a little bit different, though. The horizontal scale, I should use green. The horizontal scale is every 5 for one box, while the vertical scale, you'll see in this case, is going to be every box represents 1/5. So, it's not the same scale. So keep that in mind. Now, so when 10, we have 10 here. D is 10. Our height will be 8. So here's 8. Okay. And then when D is 15, I'll make sure it's kind of bigger. So if I have to graph this, I can see it now. So when D is 15, the height is 10.5. So here's 10.5, between 10 and 11. When D is 20, we have a height of 12. And when D is 25, the height is 12.5. So notice that basically the height kind of slows down a little bit. Okay, arcs, and now it's going to go back to when 30, the height is 12. 35, the height is going to be 10.5. Let's make sure I get this in the right place. 40 is going to have a height of 8. 45 will have a height of 4.5. And 50 height of 0. So it comes back down to the ground after it travels distance of 50. All right, so there you go. Now we can connect these, and we actually connected a graphing calculator too, get a set of settings, which I'll show you how it's done. But the question now is, what is the maximum height? And it looks like the maximum height where the ball reaches is going to be, in this case, max height at 12.5 feet. Feet? Is it feet? Does it say feet? How else I put units on the ground? Doesn't even say the units. So 12.5 units. I'll go with that. 12.5 units. Okay, and the max height's occurring here. At that height there. That's the highest point that we see. And we see kind of like the middle point of all these. And it says what value of D is it to reach the height? It looks like the D value is going to be here, 25. Okay, so here D is equal to 25. A coordinate we write down in this case would be independent variable 25. Well, the height, the dependent variable is 12.5. So that's a coordinate there. 12.5. Sorry, it looks pretty bad. I should just type it out. I'm going to type it out. So, sorry about that. I would get more work into the video with my time if I didn't make so many mistakes. I know. Sorry about that. I'm trying. Okay, so our coordinate would be 25, comma 12.5, where the independent variable is 25 and the dependent variable is going to be 12.5. Okay, now here's the thing: how will we be able to graph this on a graphing calculator? Because the calculator has a certain window, so let's talk about that. We already have in this case the y equals. Okay, now we won't change the window because right now we graph it, it looks like this. And we're totally missing it though. But let's consider our window though. Our window, which we can set our max and min, our smallest x value will be 0. And our x max will be 50. Okay? Now, I'm not sure if you guys have learned how to do this. No, you can manipulate the window. And so we're going to start on the leftmost x value as 0. The rightmost x value is going to be 50. Now, we have to change the windows for the y, but we are allowed to do the following. As long as we know what our horizontal window is, we can use what's called zoom, scrolling all the way down to 0, something called zoom fit. Zoom fit is 0, and so enter. And so now we see in this case, we see here the highest value. Okay, so now calculator can graph this to you. Very nice. It can also calculate the location of the highest point. We use second trace or calc. And we want to find in this case something called maximum. All right, so that's choice 4. So I'm going to show you how this works out. Notice it's already kind of found for us, but just in case, here's what we do. Because right now it's 25, 12.5. So we're going to move the cursor a little bit left of the highest point and hit enter. This is called the left bound. So we're basically only taking x values to the left of the highest point, we believe. We're going to bring the cursor over to the right of the highest point. Notice it's past the hill, over the hill. Ooh, okay. And our right bound will be here. So trapped between those two vertical lines is where we believe the highest point should be. So we're going to tell the calculator, find the highest point between them, and it's going to tell us, in this case, now notice it's 25.000003. It's making a summation in this case. And so we still find in this case, it's still be a 25, 12.5. Highest point at 12.5. So this is one of the ways we use a graphing calculator, which costs quite a bit of money, to help us find our maximum value too. In case you were never showed how to do this, in Algebra 1, this is one of the nice things in the case. So I want to make sure we know how to do these. Okay, ladies and gentlemen, I hope you found this helpful. I'm going to make this full page and take a look. This ends our lesson homework review for our lesson 2, function notation. Again, if you found this video helpful for any parts, whether you're using the calculator, graph things, scale in this case, give us a like. Please leave comments and questions and feedback in the comment section below. Make sure you also subscribe to the channel and turn notifications, because we put in the new videos for new lessons regularly. We'll make sure you guys are alerted to those things. Okay, all right, ladies and gentlemen, thanks so much for watching, and I appreciate you guys coming to the channel to watch. I hope that it was helpful to you guys and you're learning Algebra 2. See you in the next video. Take care and be safe.